Good morning, all. Today we will discuss the Biot law, an important law in the field of magnetostatics. Now, before discussing the Biot law, let us revise some points from electrostatics that we have already studied. In electrostatics, we have stationary charges. They produce electric fields that are constant in time. In electrostatics, we have stationary charges. They produce electric field that are constant in time. Hence, we will use the term electrostatics. Electrostatics is basically the study of or the theory of stationary charges. Electrostatics, it is a theory of stationary charges. They will produce electric field that are constant in time. Now, in magnetostatics, we are studying about steady currents. The steady current produce magnetic fields that are again constant in time. Steady current produce the magnetic field that are constant in time. So we will say it is magnetostatics. Magnetostatics. Magnetostatics is basically the theory of steady currents. Thus, we can say that the stationary charges produce constant electric field. Now we have electrostatics and steady currents that produce constant magnetic fields. So you have magnetostatics. Now let us discuss the Biot law. Suppose a current is flowing through a wire. Now it will generate magnetic field. Now let us evaluate the magnetic field due to the conductor carrying current. The Biot law basically states that the magnetic field dB at any point due to an element of conductor carrying current is proportional to the strength of the current. Here the P is the point where we need to evaluate the magnetic field, which is at a distance r from a small element dl on the current carrying wire. Now the magnetic field dB at the point P due to the small element dl of a conductor carrying current is directly proportional to the strength of the current. Then it is again directly proportional to the length of the element dl, and it is proportional to sine theta. What is sine theta? Sine theta is the sine of the angle theta between the element in the direction of the current, that is dl, and the line joining the element to the point P. Sine theta is the angle between the element dl in the direction of the current and the line joining the element dl to the point P. And also it is inversely proportional to the square of the distance between the point P from the center of the element dl. Thus, dB, the magnetic field at any point due to an element of a conductor carrying current is directly proportional to the strength of the current I, the length of the element dl, the sine of the angle theta between the element in the direction of the current and the line joining the element to the point P, and it is inversely proportional to the square of the distance r of the point P from the center of the element. That is, we have dB is proportional to I, dB is proportional to dl, dB is proportional to sine theta, and dB is proportional to 1 by r square. And together we can say dB is proportional to ideal sine theta by r square. Or we can say dB, which is equal to a constant multiplied by ideal sine theta by r square. Here the constant is mu 0 by 4 pi. So we have dB, this is equal to mu 0 by 4 pi ideal sine theta by r square, where mu 0 by 4 pi is a constant. The value of mu 0 is equal to 4 pi into 10 raised to minus 7 Henry per meter. Mu 0 is the permeability of free space. Next is the vector form of Biot law. We have dB, this is equal to mu 0 by 4 pi ideal sine theta by r square. Now multiply and divide by r. Now the expression modifies to mu 0 by 4 pi ideal sine theta r by r cube. Now you can write it as mu 0 by 4 pi I into dl cross r by r cube. Now the equation transformed to a vector form. Here dl r sine theta is replaced by dl cross r because a cross b is ab sine theta. So dl cross r is dl r sine theta. Now every vector r can be represented as its magnitude multiplied by the unit vector in the direction of the vector. So you have r can be written as r cap. Now dB, that is equal to mu 0 by 4 pi I dl cross r is replaced by r cap, vector r is replaced by r cap by r cube. Thus dB becomes mu 0 by 4 pi I dl cross r cap by r square, because r and r by r cube modifies to r by r square, 1 by r square. This dB is equal to mu 0 by 4 pi I dl cross r cap divided by r square. This equation dB, this is equal to mu 0 by 4 pi I dl cross r by r square, which is the magnetic field due to a current element idl at a point P, which is at a distance r from the element dl. dB, this is equal to mu 0 by 4 pi I dl cross r cap by r square. This is the magnetic field due to a current element I dl at the point P. which is at a distance r from the element dl. Now, what is the magnetic field due to the entire segment of the wire? How do you calculate the magnetic field due to the entire segment of the wire? Just integrate dB. Now, the magnetic field at point P due to the entire segment of the wire, which is given by B, that is integral dB, and that is equal to mu 0 by 4 pi integral I dl cross r cap divided by r square.